Hello and welcome to another video. In this video, we're going to be doing valid palindrome 3, and in the problem, you're given a string s and an integer k, and you want to return true if s is a k palindrome, and a string s is a k palindrome if it can be transformed into a palindrome by removing at most k characters from it. So in this first example, if we remove the b and the e, then ACDCA is a valid palindrome. And in the second example, there is no way to remove it. There's like too many characters. So let's kind of walk through what first of all we need to figure out if something is a palindrome, like kind of how we do it, right? So essentially, let's go through the first example, and then we'll go through the second example. So I'm just gonna draw this out in an array, and we'll have all of our characters. So we'll have A, B, C, D, E, C, A. Essentially, like the original problem of like valid palindrome is pretty easy, right? You just start over here and over here, and you just compare letters and you make sure they're equal. And if they're equal, then you move these in and you move these in until they're not. So like these two letters would be equal, then you would move these in, and now they're not equal. So basically here you have a choice, right? You have to remove one of these letters, and you can either remove this letter or you can remove this letter. So let's say we remove the left letter. Then we go in again because we removed it. So these are equal now, so we'll move these in. Now you have a choice, remove one of these, and either one of these removed would make it a palindrome, right? Because then your left and right would be right next to each other, right? And then you're done. So let's say you remove this, and these are both over here, and now this is a palindrome, right? ACECA. Or if we remove the other one, it's also a palindrome. So right, so like this is also a palindrome, but you might not necessarily like B might not necessarily have been the right choice to remove. So if B didn't work out, then you'd have to try the other one. You'd have to remove C, and then you do the same thing. So essentially, we can write this down, right, as for like what we want to do. So we have a left and right pointer. If the letters are equal, move them in. If they're not, try getting rid of both, and then getting rid of a letter just means only move one pointer in and increment deletions. And so that's kind of like ideally that's what we'd want to do, right? Every time two letters aren't equal, we have a choice, and then we want to like recurse and see if that works. So this is looking like a DP problem, right? Anytime you have a choice between two things, and then you want to like recurse and figure out like which one of these gives you the best solution. That's like typical DP. So ideally, we want to have something like a left pointer, a right pointer, and a deletions made or something, right? Like that would make sense. And then you would basically just check, like, is it, if you have this, then you would just try to figure out, like, is it possible to do this or not or something, right? So the problem is, in this length, it's actually 1,000 characters, and deletions can be up to 1,000 characters. So if we do it like this will be 1,000 times 1,000 times 1,000, which won't pass, right? Because that's going to be too big. So instead of doing this, what we can do is we can just, and this is kind of tricky, this took me a little while to figure out. I tried to do a bunch of other things. So you do have to try deleting both. You can't just say like when the characters aren't equal, delete one or the other. So basically what we have to do is we have to pick one or the other to delete. And then we're actually going to store in our output the deletions. So our state will just be left and right. And we're just going to store the deletions in the output, and then that'll make it a lot easier, basically. So what that's going to look like is we will just have this as our state, and then our result of the DP will be the deletions. And then this is going to be fine, right? Because this is going to be only 1,000. So let's kind of write this down in like all the cases and stuff for DP. So state, we will just have this left and the right pointer, and they will just be initialized in the beginning to the start and length of the array, right? So we'll just make it like over here and over here. So here and here, right? Like 0 and then the length. And our base case. So if you think about it, like what's a base case for checking letters in a palindrome, where you just keep moving them in until the left is equal to or greater than the right, right? Like you keep moving them in, keep moving them in, keep moving them in. Once they're on the same letter, then or the left is past the right, then you're done. So that's kind of the base case. So the base case is, let's write that down. Base case is left is greater than or equal to right. We want to just return 0 here. We don't need any more deletions. We're done. And recursive. So there were the two things, right, where we basically had, let's move this down. Okay. So we have two recursive cases. So one, letters are equal, do dp of left plus 1 and right minus 1, right? Just move the pointers in. And letters aren't equal. You have a choice, delete either one. So it's going to be the minimum of dp. You move the left in, keep the right the same, or you keep the left the same and you move the right in, right? Either one of these. And you basically do this, and then you just check at the very end, is your original dp value, like we will just get a min value here, right? Like what's the min deletions we could have made to make this a palindrome? And we just check, is the dp from 0 less than or equal to k? And so k is going to be the variable we're actually storing, and we're going to be able to just check, like, is the dp value with these two things, now that will pass, less than or equal to k. So let's take a look, and we can code it up. So what we need is a cache, as always. And what we're going to have is the dp, right? So it's going to have a left and a right. We have our base case, so if left is greater than or equal to right, let's return 0. And then we have our cache case, so it's left, right, in cache. Let's return cache, left, right. And now we have our two recursive cases, right? So if the characters are equal, so if SL equals SR, then we want to cache this and store it. So we'll just do this. You could have a result variable as well, but there's not much here, so I'm not going to use it. So if these are equal, you just move them in. Otherwise, you have the two cases where you're simulating deleting a letter. Simulating deleting a letter just means try to move the left in, which means you deleted the left letter, or try to move the right in, which means you deleted the right letter. So let's do that. So cache left, right. Now, what's the count of deletions for this? So here, if they're the same, it's 0. But here, we did delete a letter, so it's going to be 1 plus the minimum of these two things. So dp of moving the left in, and then the other choice is moving the right in. So left, right, minus 1. And yeah, that should be it. And now we can return cache left, right. And finally, we just need to check, is the dp of like our first dp. So where do these things start? So these two things are going to start, the initial state is left starts at 0 and right starts at length of s minus 1, right? You want to start the first character and last character and then move them in to check for a palindrome. And so if this is less than or equal to k, then this is fine. So let's try to run that. And it looks like we have something that works. So let's talk about some optimizations. So here you can see that our recursive case, the left and right are only moving like one index maximum, right? Which means we can space optimize either one of these dimensions. And so I think what I'm going to do is we're going to just try to go from memoization directly to bottom-up space optimize just by thinking about what we need to space optimize and then have a template for it and then just try to do it like quickly, because it doesn't really do you any good to go from this to 2D bottom up and then go from that to 1D bottom up and have pictures of everything, because, and I do have, and I will include like the long video of that if you want that. Like if you've never seen it before, it's obviously good to have. But once you have that, you really want to be able to go from one to the other in one step. And then that will take you around, let's call it 5 to 10 minutes. And that's actually doable. Because if it takes you like 30 minutes to go from memoization to bottom up because you have to draw the pictures and everything, then it's kind of pointless, right? You're never going to be able to have time for that in an interview or like a competitive programming thing or anything. So you really want to get that time down and just develop intuition to be able to do it pretty quickly. So that's what we're going to do. So first we're going to have a template. So we're just going to pseudocode like what we want to have. So what we want to have is we want to have a DP array here. We want to figure out what dimension we're getting rid of. We're just going to get rid of the left, and I'll show you kind of how this is going to work. You can get rid of either one. So you're going to have a nested for loop here. So you're going to have like for something, right? Because essentially this is, you can recognize this is a this is a two-dimensional DP problem. So we pretty much always have a nested for loop. So for something else, and then essentially every time in this first loop you're going to make a new DP array. Let's make some more space here. So yeah, and then you're going to fill out new DP array. And then finally, so it's actually going to look like, let's actually tab it to make it look kind of correct. So it'll be like this, like this. Now finally, at the end of this for loop, we will set old DP equal to new DP. And this is going to be for dimension we are getting rid of. Right? And then this is going to be dimension we are keeping. So pretty much almost all space optimized bottom up, if you're going from 2 dimension to 1 dimension, will look exactly like this pseudocode. And so let's kind of fill it out and then figure out like what needs to go where. So for the DP array, remember we're getting rid of the left dimension, so we're only keeping the right dimension. So for a word like this, we are just going to say that, and we also want to go from a number we know to a number we don't. So what we're going to do is we're going to say we're going to go from the left and the right being on this last index. And then what we want in the end is we want an array of the left being here and the right being here. So if the left and the right are on the same index, and we're just going to widen it out, right? Like we know, because our base case is basically this. So this is the one we're going to start with, right? You want to start at the base case, and then you want to like end up being at what you actually want. So if the left and the right are on the last index, then we know the DP of that is 0, right? Like we know that this is we know that for sure. And also, in theory, we like can make our array, like you can make this array bigger, right? Because if the left and the right are on this index, technically this will only be an array of like length 1 for the right, and then it would get wider and wider and wider, but we don't need to do that. We can just always make an array of every single right index. But this is one that we know, right? If the left and the right are on the same index, then the DP of that's going to be 0, because if you only have one letter left, then you have a valid palindrome. So we're going to start with that. So we're going to say DP equals 0, and we're just going to always keep the length the same, even though you can make this smaller, because theoretically, if the left is over here, there's only one, and this is going to be actually like this. If the left and right are over here, then the length of this is only 1. Then when the left starts here, the length of it will be 2, and so on. But I'm just going to, for simplicity, make it length of s. You can optimize this further to actually make this thing smaller. So we're going to start with the left and right being here, and then we are going to go backwards for the left. So we'll start here, and the left will go here, 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 here. And essentially our DP is the value of all these different right indices from 0 to length s. And then we're going to look at our memoization code and figure it out. Okay, so the 4 dimension we're getting rid of is going to be the left one. So we'll just say like 4 left in range. And where are we starting? So remember, we start with our left being on the very last index, which means left is at length s minus 1. So that's this case here. Now we want to go from everything below that. So this will be length s minus 2. And we're going backwards up until L is the first character. Okay, now we have a new DP array, which is really easy. Usually it's just going to be a copy of this. So we'll just have this. Now the dimension we are keeping is going to be the right dimension. And here we want to look at how, like, when we are recursing, what we need, right? Like, these values, what values do they need? So this value relies on right minus 1, and this value relies on right minus 1. So if the value we need relies on right minus 1, then we want to fill out the right left to right, right? Because if the value we need relies on right minus 1, if you fill it out right to left, if it relies on right minus 1, that can't happen, right? Like let's say we have some values here. Let's say this is like 0, 0, 0, 0, 0. If we fill it out this way, well, if this relies on right minus 1, that's not filled out yet. So that's kind of why you want to look at your memoization code and just figure out like which way does this for loop go and which way does this for loop go. So the left relies on left plus 1, which means you're going to want to fill out the left backwards. And obviously, we want to end up with the state where left equals 0, right? Because we want the left to start at the very first character. So we're going to fill out the right in the forward order. So we're just going to say this is going to be length s, right? We just want to go from 0 to the last character. Now we fill out the new DP array. And so when we fill out the new DP array, remember left, we can write this down as well. So in our particular case, left is new DP, right, or left is new DP, and left plus 1 is old DP. So anytime we have a left plus 1, that's the old DP. Anytime we have a left, that's the new DP, because we're filling out our left backwards. And for every new index of left we're filling out, we're just making a new DP array. And right is just the index before this in the column, right? So right is going to be the index before this, and then that's how we figure it out. So let's take a look here, and we're going to literally have this exact code. We can even copy it in and then just change it. So that's why it's kind of nice to have the memoization, and then you should just be able to go straight away from that to this. So now we just have to make some changes here. So this is not going to be cache anymore. This is going to be new DP. And so this is cache left, right. Remember, we don't have a left anymore, so this is just new DP right. Now let's take a look at our actual constraint here. So this is DP left plus 1. So remember, left plus 1 is the old DP. So we can change this to DP. Left plus 1 is the old DP. Like, that one's done. Now right minus 1 means the index needs to be the old DP at index right minus 1. So this is going to be like this. So that part's done. Now, same thing here. It's cache left, right, but now we have new DP right because we don't have a left dimension. Then this is the same one. So that's why I said the code is very similar. You just need to figure out like what these need to turn into, and then it's kind of easy. Let's get rid of this. So let's take a look at this. DP left plus 1, that is the old DP, right? I think I have it right here. Yeah. So left, yeah, so this is that. And it's going to be the same thing. We have the min. So old DP, so DP, and right is still right. So right is still right. Right minus 1 is still right minus 1. Now, let's take a look at the other index. So this is left. So remember, left is new DP. So this is going to be new DP. And right minus 1. And now, finally, we just need to do this like set old DP equal to new DP. So old DP equals new DP. So now, at the end, we basically have a DP array where the left index is 0, and it's going to have every single right index, right? So let's say for this A, B, C, D something, we will basically have seven characters. So let's say like our result, we can even print it here. So we can print new DP, or DP, sorry. And we can, for now, return 0 or something, just to see what that looks like. So we can comment this out, print it. And we could see, so here's our DP array. So this is when the right starts at 0, when the right starts at 1, right starts at 2, right starts at 3, 4. So this, actually, I forgot one more thing that we didn't take into account. So in our original memoization, we made sure that if left is greater than or equal to right, we return 0. So when we fill out the right, we actually want to make sure that the right starts at the left value, right? So for example, if our string is A, B, C, D, E, C, A, if the current left we're filling out is here, that means the right shouldn't be over here. That wouldn't make any sense, right? So the leftmost right value should be the left value you have. So if the left is here, you want to have this one, this one, this one, this one, this one. And basically the rest of them will just be the zeros, but it doesn't really matter. So we need to add one more thing here. So this needs to start at the current value of left, which is just left. Yeah. Does it need to start at left? Yeah, I think you can start at left or left plus 1. I think technically you can start at left plus 1, because if you start at the left value, that will always be 0. So I think this will work either way. Pretty sure. So this will just be 0, but we'll test it out. So now if we actually print our new DP, or our DP, this should be, so here it is. Let's see if that's correct, actually. Okay, and then now, so what do we want to return? Like now that we have our new DP. So essentially, we have L at index 0, and then we have right at every single one of these. So what do we want to return? Well, we want to return when right starts here, right? We want to start the left over here, and the right equals here. So that's what we want to return. So we want to return DP of the very last index, because that means the right starts here. Let's see. Okay. Let's see. So yeah, I do think this might have to be a left plus 1, but actually I don't think that should matter, to be honest. Let's use a test case. Yeah, I think we did something else wrong here. So let's just double check. Oh, right, we forgot one more thing. Yeah, so like I said, this doesn't matter. So we don't want to return DP of -1. DP of -1 just means this is how many deletions it took when left is 0 and right is the last index. But if you look at our old code, we want to return this, right? We want to return, is that less than or equal to k? So that's what we want to return. Okay, there we go. And like I said, this should work either way. Like this should be fine. Both of these should be fine. But you do want to make sure that your actual right value starts at the left, because it wouldn't make any sense for the right to start below the left, right? Like if the left is over here, then the right shouldn't be over here, right? Because the left should always be less than or equal to the right from our old code. So that's kind of the idea. You want to really go from the old code to this without having to draw out the pictures in a realistic amount of time. So like I said, like maybe 10 minutes. So this is kind of the template you want to follow. Once again, you just want to have your DP array. You want to have all your dimensions. And then your topmost dimension should be the one you're getting rid of. And then that way, you just make a new DP array every time you iterate here. So your new DP array is your current value of whatever you're getting rid of. The innermost dimension is the one you're not. And then you literally just look at your memoization, realize like where, like if you're getting rid of the left, which left is your new DP, which left is your old DP. These should be the same, and then you just call these appropriately. So the code is very similar. Yeah, so we could do this, and so you could see the space is a lot more efficient than it used to be. And I think when I ran it a few times, it just like was faster. Yeah, so in theory, performance shouldn't really increase too much. In practice, it does, because I think memoization is a little bit slower with the caching as opposed to like using an array. But the space should definitely increase. So let's go through the space for this one and the time. So essentially, we have the left and the right, which are basically O of n. So this is O of n squared. And for the space, now that we only have one dimension, that's O of n. So we cut it down from O of n squared to O of n. So yeah, so what I will do in the future is we'll just go over the memoization solution, and then we'll quickly bring this template up and just code up the bottom up. And I think that makes the videos like not too long, because if I draw everything and stuff, that's like an extra 30 minutes. And I'll always like link the video of how to do it, but I'm not gonna do it in every video, because I think that's like a time sink. And I don't think it's very practical once you've like been introduced to it. I think you actually want to be able to go from this to this, you know, in like 10 minutes or something, or less. And the more you practice, the faster you'll be able to do it. So hopefully this is helpful. And if it was, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.